Hi everyone, welcome to Unit 8, Lesson 2, Attributes of Rectangular Prisms and Pyramids. So two major categories of three-dimensional shapes that we're going to be talking about, prisms and pyramids. Okay, so a prism, this is an example of one right here. This is a right rectangular prism, and that's where the bases, the opposite sides, like this side and this side, are rectangles. So that's what defines what type of prism it is. If those were triangles, it would be a triangular prism. Okay, but with a right rectangular prism, it has six sides or faces, and they're all rectangles. Okay, so I labeled one of the faces. This would be a face. It's all the sides of like a box. Okay, think of like a shoe box. Right? It has six sides. It has a top, it has a bottom, it has a front, a back, and then like a left and a right. Okay? Also, all of the angles that are on it are right angles, which makes sense because they're all rectangles, right? And the rectangle has to have those right angles. Where the faces meet, those are called the edges, and where like three of them meet, right? Like the corner, like right, that would be like a general word that we would use, but the more specific word would be a vertex, where they meet. And they also have a width, they have a length, and they have a height. Okay? In your lesson, you're also going to see that this is an example of a cuboid. That's quite the word, isn't it? Cuboid, which just means it has a box shape. Okay? And just another thing about them, another attribute about them is that they have identical bases, right? So those, like if I'm considering these as my bases, or I could consider the top and the bottom, it doesn't really matter in this particular case, that but they're identical. And also the identical lateral or opposite faces. So lateral faces are the faces that are not the base. Okay? And we'll look at that in cones as well. So here's a couple examples, or not cones, oh goodness, pyramids. I'm so sorry. Um, this drawing is not a very good drawing, and I apologize for that. But this is an example of a triangular pyramid. And so all of the sides are triangles. And so in this case, the base, or this would be like the bottom of the pyramid, is a triangle as well. Okay? And then all of the different sides, so let me see if I can use pink, maybe that'll show up well. So like here's one, there's one side, here's the other side, and then if we were looking at this straight on, this whole thing, like right here, the whole thing would be like the front side of it. I wish I had an example to show you. But anyway, they're all of the sides of them are triangles, including the base, which is the one it's sitting on. So you can see here, this drawing is a little better. This would be called a square pyramid because the base is a square. Okay, so pyramids are defined, and prisms, they're both defined by their base shape. Okay, and then the vertice that is opposite of the base is also known as the apex. Alright. I have one more drawing that you'll see this in your lesson too, and hopefully the pictures in there are better than mine. This would be a pentagonal pyramid because the base is a pentagon, a five-sided shape. Okay? Oh, and I also said the lateral sides. So we have the base and then we have the lateral sides. That's all the sides besides the base. Okay? So in this case, this one would have like 5 lateral sides, okay, because there are 5 triangle sides, and that's what that means. All right, so let's look at some examples. So this is, for my first problem, this is actually number 1 on your practice. How many faces, vertices, and edges does a right rectangular prism have? So we need faces, we need vertices, and we need edges. Well, let me just draw one. I mean, we can look at the paper that I had on there before, but I could just draw one real quick so we can look at it. I do a decent job of drawing those compared to the the pyramid, the triangular pyramid. That one was so hard. Okay, so faces, those are, like I said, those are the sides of it. And right rectangular prisms have 6, okay? They've got a front, a back, a top, a bottom, and like a left and a right, okay? So 6 faces. And then vertices, we've got 1, 2, 3, 4 on top, 5, 6, 7, 8 vertices. Remember, those are like the corners. And then the edges, that's where the faces meet. So let's see, let me use a different color. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 edges. Okay, so that should help you with number 1 on your practice. The next problem, number 2, there is a row of 2 triangular pyramids and 1 pentagonal pyramid in a display at a museum. How many lateral faces are there? Okay, so I'm gonna attempt, let's see, maybe if I draw it like this. Okay, that's not terrible. That could be like the, that would be a triangular pyramid. And then let me draw another one just like it. Ish. Oops, that one it could be. Okay, so we've got 2 triangular pyramids and 1 pentagonal. Ooh, the pentagons, those are tough. Let's see, we could go like that. And you don't need to draw these, I'm just trying to help us have a visual. Okay. And the dotted ones, those are just like, we can't technically see them, like if this were a solid figure. So, how many lateral faces are there? Well, the lateral faces are the faces that are anything but the base, okay? So I could color in the base if I wanted. So here's my base, that's a triangle. Here's my base, that's a triangle. And then we've got the pentagon here as well, right? So with this though, and it's going to be kind of harder to draw or to show it on these triangular pyramids, but so any side that isn't the base, right? Well, there's 3 sides connected to that base on each of these, right? There's this front one here, and then there's like the one in the back. So this would be 3. This one would also be 3. This one, there are 5 lateral sides that are connected to the base, okay? And they all meet up at the apex. So all together, we have 3 plus 3 is 6, plus 5 is 11. Okay, that's how many lateral faces there are. Now this next one, number 3, this is from your quick check, and it is number 1. Describe the specific attributes, okay, specific attributes of a prism, all right? So let's talk, like, think prism, right? So first off, a prism, it's a 3-dimensional shape, all right? It has opposite bases that are identical, and the lateral faces are also identical, okay? And that's in right prisms. In right prisms, that's part of that, is that they would have identical lateral faces. But, so for A, a prism is a point? No. A prism is a point where 2 or more line segments meet. No, that would be like a vertice. Okay. B, a prism is the top or bottom face of a solid object. Nope, that's, let's see, so this would be a vertice. Can't be this one, that's the base. C, a prism is a figure that has height, length, and width. Well, that could be it. Okay, but that's not specific. This says the specific attributes of a prism. So D, a prism has parallel identical bases and identical lateral faces. Yes. At least with the right rectangular prisms. That's true. Okay? So, I hope that helps. As always, reach out if you need extra support, okay?